Today we're going to stay in section 5.4, still talking about our complex numbers. Instead of talking about multiplication or addition and subtraction, we're going to talk about multiplication and simplifying some fractions with complex numbers in them. If we look at the first problem here, we've got 5i times the quantity negative 2 plus I. So if this were just a negative, or if this were just a 5 out front, you guys would probably all tell me that we're going to use the distributive property. And that's exactly what we're going to do here. We're going to take 5i times negative 2 and 5i times I. Again, i's work just like they do, just like variables. So instead of i's, if you were to put x's in there, you're going to do the same process. So 5i times negative 2 is going to give me 5 times negative 2 is negative 10. And I just tack that I behind there. And 5i times I, well, now that would be like 5x times x, which would give you 5i squared. And if you guys remember from the last video, we are dealing with I, which is the square root of negative 1. But I want I squared is going to be the square root of negative 1 squared. Remember from the last video, when we are squaring a square root, the square root is gone. So I squared is just going to be negative 1. So you can plug in a negative 1 for this I squared, and you end up with negative 10i plus 5 times negative 1. Which, when we simplify that down, that's going to be 10i minus 5. And remember, I said we want to write all of our answers in standard form. So this negative 5 needs to come first. So you get negative 5 minus 10i. And there's your answer. Our next problem. We're going to take the quantity 7 minus 4i times 1 plus 2i. So now we're multiplying two complex numbers instead of just multiplying an imaginary number by a complex number. One method you could use is you could use your FOIL method that we worked with in section 1. And that would work very well for you in this case. I'm going to show you a little different method. I call it the box method. You guys will see why here in a second. It's because I put everything into boxes. But the reason I like the box method is because later on, this box method will work just as well as foiling, and foiling only applies to certain situations. This is one of them. But the box method will work with any sized numbers that you're going to multiply. So if we're going to do the box method, I'm going to need a box. And on the top, and this in this case it doesn't really matter, but I'm going to put the first number that I have, my complex number, 7 minus 4i. 7 minus 4i, and I'm going to put a line right in between there to separate those two terms. On the side, I'm going to put negative 1 plus 2i. Put another line in my box to separate those. And now, if you guys have done Punnett squares in science before, where you're talking about genes, you know you're just going to multiply the two numbers on the sides of the boxes. So if I take 7 times negative 1, I'm going to get negative 7. I'm going to take negative 1 times a negative 4i. I'm going to get a positive 4i. If I take 7 times a positive 2i, I'm going to get a positive 14i. And 2i times negative 4i means I'm going to get negative 8i squared. And now we just collect like terms. So the like terms here are going to be 14i and 4i. So I end up with negative 7 plus 4i plus 14i is going to give me 18i, and I've got a negative 8i squared. But if you remember from the last problem, we know something special about this I squared. So we're not done simplifying. We're going to take negative 7 plus 18i minus 8 times negative 1. So negative 7 plus 18i plus 8 is what we end up with. And now we collect some more like terms. We end up with negative 7 and positive 8. So that is going to give me 1 plus 18i. And that is my final answer. So there's the box method. It works very well. I'll show you guys foiling here in the next problem that we're going to do, and I'll help you set up the box as well. But I like the box method. It's very visual, so feel free to use that for your multiplication needs. If we look at this problem, 6 plus 3i times 6 minus 3i. If we're going to set up our box, again, start with a box. So I'm going to have 6 plus 3i, split that there. I'm going to have 6 minus 3i, split that there. So I've got 4 boxes within my one big box here. And again, multiply your sides like you did last time, collect your like terms. Which, this is just a different way to do your FOIL. If we're going to do FOIL, we're going to multiply our first. We're going to take 6 times 6, the first term in each. So I'm going to get 36 outside. 6 times negative 3i is going to give me negative 18i. Positive 3i times a positive 6 is going to be a plus 18i. And the last term in each side is going to be positive 3i times a negative 3i, which is going to give me a negative 9i squared. Collect what like terms we can. We've got our negative 18i plus 18i, and when you add those together, they cancel out to 0. So you're going to get 36 minus 9 times negative 1. Whenever you see that I squared, plug in negative 1. So 36 plus 9 is going to be 45. And there's our answer. It turned out that when we multiplied 2 complex numbers together, we ended up with a fully real answer here. Now, this was not a coincidence. This is actually what we call the conjugate. And this happens every time. It goes back to your difference of squares factoring. When you multiply it out, those middle terms cancel out. So this is what is called a conjugate. And all it is that the signs in the middle are opposites. The reason we do that is so that we can, when we multiply those together, we get a fully real number, in this case, that 45. The reason I bring this up is because we're going to write the quotient in standard form of 5 plus 3i divided by 1 minus 2i. In order to do this, what we are going to need to do is we are going to multiply by the conjugate of the denominator, that number in the bottom. So I need to multiply both of these by, well, the conjugate, I look at the sign, it's minus 2i, so I'm going to multiply by 1 plus 2i and 1 plus 2i. The reason I can do this is since I'm multiplying by the same thing on the top and bottom, this is really just a fancy way to write the number 1. So I'm not changing the value of the fraction, I am just making it look different. Now, if I'm going to FOIL these, it helps, you can put them in parentheses. Actually, let's do the top by the box method just to give you guys another example here. I like it. Maybe you guys have seen it. Maybe you haven't. But yeah, 5 plus 3i and 1 plus 2i. Cross there. And I end up with 1 times 5 is 5. 1 times 3i is 3i, positive. And 5 times 2i is going to give me a positive 10i. And 2i times 3i is going to give me 6i squared. So the numerator of this bad boy, after we collect some like terms, the 10i and the 3i, is going to be 5 plus 13i plus 6i squared divided by, and we can FOIL this one again just to give us some variety. I'm going to take my first 1 times 1, which is going to give me 1. The two outside numbers, 1 times 2i, is going to be plus 2i. Pay attention to your signs. Inside, negative 2i times 1 is going to give me minus 2i. And negative 2i times positive 2i is going to give me minus 4i squared. Again, the 2i minus 2i will cancel out. And what we can do is plug in our negative 1s for our I squareds. We're going to get 5 plus 13i. Looks a little too much like a B. 13i plus 6 times negative 1 all over 1 minus 4 times negative 1, which gives us 5 plus 13i minus 6 all over 1 plus 4. So I get 5 minus 6 is going to give me negative 1 plus 13i over 5. And because we have to write in standard form, a plus bi, I need to split this fraction into two separate fractions. To do that, all I do is keep the numerators the same and put the denominator under each of them. So what we're going to end up with is negative 1/5 plus 13i divided by 5, and there is the answer we're looking for. So dividing takes a little more work. Or I guess we didn't really divide it, but changing it into the acceptable form, we do not like i's in the denominator, so that's why we had to go through all that. But at the end, it's really the same process that we've been doing the whole time here. So hopefully this makes sense. If you guys have any questions, let me know. We'll get some practice in class, and I will see you guys next time.